Hey guys, I hope you're having well, it is Wednesday night, Tuesday night, 9 o'clock. Oh, I need to be asleep. Anyway, um, new chapter, yay. Section 7.3, multiplying and dividing rational expressions. Here we go. First one, to get three key concepts. What a rational expression is the quotient of two polynomials. You know what polynomials are. That's what we talked about all last chapter. Simplest form is when the numerator and the denominator do not have any common factors. Restrictions are the values that make the denominator zero. We talked about all our restrictions last time, so we'll be moving forward with those. All right, so simplify, stating any restrictions to the variable. So if I take a look here, 27 and 9 give me -3. X cubed divided by x to the fourth would be 1x on the bottom. My y's cancel out. Now, my restrictions, we know x cannot equal 0 and y cannot equal 0. Basically, what's in the denominator can never be equal to 0. Here's the thing, though. My real answer that I need is just this. That's all I need. The only reason I need that is because they think that we are incredibly smart, because seeing that x here in the denominator, we know that x cannot be 0. All right? So this is all you need. This is just fine if you keep it in there as well. So whatever you like. All right, so for this first example, or I guess second example, you want to factor. We get 2x plus 1. We get x minus 2. We get x minus 3 and x minus 2. Most of the time, something's going to go away. Boom, there you go. Up with 2x plus 1, x minus 3, where x cannot equal 2. Again, you could have the 3 if you want, but it's not necessary. Not too difficult. All right, let's take a look. When you're multiplying rational expressions, you're better off factoring your numerator and your denominator, make your restrictions, and then cancel out your common factors. All right, so let's take a look. Here, 2 times 4 is 8. So there goes my 8s, and I'm left with 7. 3 and 4 is 7. 7 divided by 1 is 6. And then my y's, 4y's divided by 3y's is 1y. Now, if I look at my final answer, there is no restriction, right? So therefore, I need to go back and write x cannot equal 0, y cannot equal 0. So, like I said before here, if you state your restriction before you cancel everything out, you won't miss it. All right. So doing this problem, we could have started right here with our restrictions. So that's our answer here. All right, next one. Here is your fun difference of 2 cubes. Now, again, be smart, guys, and take a look to see what you have. I see I have an x squared plus 3x plus 9. And guess what? I'm going to assume, unless I'm a really good factor person, that this is factorable. This guy goes, I'm left with x plus 2, x minus 3. All right. Again, if you want it, you could have x cannot equal to 3. And now with this guy, we know it's not factorable, so we don't have to include it as part of our inclusion restrictions. All right, so you are going to do this for me tonight. There's number 1. And you are also going to do this for me. That is your number 2. All right, getting to talk about dividing. Dividing, we use that flip, but we know we're talking about take the reciprocal, right? All right. Take the reciprocal and multiply. And again, restrictions where necessary. All right, so here's my division. X plus 4, x minus 1, x minus 3, x plus 4, divide, take the 2x out, x minus 3, x plus 1, x minus 1. Now I can do my restrictions here, or I can wait. X cannot equal 3, negative 4, negative 1, or 1. Here we go. Bye-bye. 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 So I'm left with 2x over x plus 1. All right. So the only restriction that's not necessary is that. But again, if you have it, it's fine. All right. I'm going to go back here for a second. All right. I've given you 2. Here's your number 3 to do. Here is your number, number 4. And number 5. And number 6. So let's take it back to 5 again for a second. I know obviously you can pause and write these down. Pay attention. All right, you got a division sign and a multiplication sign. These are the two that are getting divided. Once those are divided, then you multiply. Here on this, what does a negative exponent do? Think about it. This has a multiplication. These are the two that are being divided by. All right. So 6 problems to do. Hopefully not too bad. And if you guys have questions, I'll be on Zoom tomorrow. All right. Have a great night. See you all Thursday.